Hi everyone, Rick Thoman with the Alaska Center for Climate Assessment and Policy here at the International Arctic Research Center at UAF. Last minute change of plan here with the inclement weather, but happy to be able to join you via this recording, and hopefully I'll be with you live as well. So we'll see if we can make technology work for us. All right, today's presentation going to be just basically focused on what happened in the past growing season in the Delta Junction area. Well, we're going to start off with just one slide, making sure we're all on the same sheet of music here when we talk about weather versus climate, and just give you some idea of some of the tools that we have to monitor weather and climate in this day and age. Most of the presentation will be that 2022 seasonal recap, and then we'll just finish up with a few slides looking at some longer term trends that might be of interest. So, weather, climate, we use these terms regularly. I think most people have this intuitive sense there's a difference. We can spell it out pretty succinctly though. Weather is basically what's happening at a particular point in time. So what's the temperature right now? What's the precipitation rate right now? What's the intensity of the sunshine right now? We tend to think of this in a little broader time frame, maybe stretch it out to a day or something like that. And of course you can have these instantaneous or near instantaneous states of the atmosphere. It could be right now. It could be what was the state of the atmosphere at 2 p.m. on the day I was born, in the place I was born, or we can have a weather forecast for July 4th, 2062 at noon. That would be a weather forecast. Now, climate is very simply the statistics of weather. So anything that you can do with a bunch of instantaneous states of the atmosphere and their measurements really is climate. So even though we think of things like the high temperature yesterday as part of the weather, in actuality, it's a climate statistic. It's the highest value of a whole bunch of temperature observations in the course of the day. Of course, we don't usually think of climate that way. Usually we think of longer periods of time, weeks, months, seasons, years, decades, centuries, depending on your time of interest. And when we think about climate, unlike weather, we often are less interested in the absolute values, but rather what they are in reference to some longer term baseline. So, for instance, we often look at departures from normal in relation to some a standard 30-year baseline. And that makes it different than, say, the weather. Normally, we wouldn't talk about, well, the temperature right now is 8 degrees above normal. Normally, we'd say, oh, the temperature right now is 28 kind of thing. So when we put those together, we can see this, these kind of sayings. Some of these you probably have heard. Climate's what you expect, weather's what you get. Climate's what's in your closet, weather's what you wear today. If you're a sports fan, you probably have heard of this guy, Babe Ruth. The long-term view of Babe's career was that he was a great home run hitter. That's the climate part of Babe's career. The weather was the day-to-day games. And of course, Babe didn't hit a home run every time at bat. In fact, there in July 1921, Babe had a bad day against the Tigers. That's the short-term part of Babe's career, and but the long-term, the climate view, he was a great home run hitter. Weather, short-term, climate, longer-term, statistics aggregate that weather. All right, so when we think about monitoring climate and weather, probably the first thing that springs to mind will be observations at a particular point, so with a weather station of some type or another. And there is plenty of those. The Delta Junction area, it has, by Alaska standards, a pretty high density of observations of multiple kinds in the area, and this is quite useful. Of course, the automated observation at Fort Greely is the longest period of record site in the area, with observations of some type. Early days, FAA mostly, briefly Weather Bureau, and since the late 1990s, the automated observation. So that goes back to the World War II era. Unfortunately, the automated observation at Greely does not do well with winter precipitation. As far as we know, it should do perfectly fine when it's rain. But in that sense, our one long-term climate site in the area is incomplete with that precipitation. Now, during the summertime, we have a lot more observations. In addition to 3 active Weather Service cooperative stations, these are sites where people volunteer to take once-a-day observations. There you can see them: Whitestone, Delta 6N, that's 6 North, although that one's more sporadic these days. And of course, Mike out at Delta 20 Southeast, taken observations since the mid-90s, really an excellent cooperative site. We also have more automated gauges that do precipitation when it's rain quite well. So we have automated sites there south of Fort Greely proper, Jarvis Creek and Bolio Lake. There's also one of these remote automated weather stations that are primarily designed to support fire weather up to a little bit to the east there of the Goodpasture River, to the north of town. In addition, we have one snow tell at Granite Creek run by NRCS, and this is quite valuable because it's one of the best, or really the only automated source we have in the area for snow information. These are different than the ASOS. They are designed to collect snow and measure both liquid and frozen precipitation. So this is quite a valuable observation, and that site has been there since about 1989, recording data. So that is quite useful. So as you can see, pretty good coverage by Alaska standards for the Delta observations, especially when it comes to what's happening in the summertime. Now, the new thing in climate monitoring are what are called climate analysis models, and these have been around for going on 30 years now. But it's only really within the last 4 or 5 years that they've had high enough resolution that we can really start to get a handle on relatively small areas. Now, all these climate analysis models they're just short-term weather models that we just keep restarting over and over again. But in addition to that, they also incorporate actual observations. So it can be things like temperature observations from Fort Greely, can be buoy information, satellite information, all kinds of information gets incorporated into this model. Now, because it's a full weather model, it outputs things that there's no actual observations for. So for instance, in the graphic here is an example of this past summer's, the total amount of sunshine that the model has relative to the past 60 years. And you can see centered right over the interior was an especially sunny summer, at least according to this model. Delta kind of on the southern edge of the sunniest, where this was in the top 5 most sunshine for any summer in this model. In addition to this kind of thing, these climate analysis models put out all kinds of information that's potentially useful to agriculture, things like evaporation, potential evaporation, things that are very important but are very rarely or never measured, and certainly not at any kind of scale, certainly not with any kind of historical record that we can rank things or say how things are relative to the long term. All right, so that's just the preliminary. So let's jump right into the seasonal recap. So let's take you back to the early spring. Of course, the 2021-22 snow season was exceptional in the Delta Junction area, and of course across much of interior Alaska. Here we're using that SNOTEL at Granite Creek, and this is a plot from the USDA website here showing the amount of water in the snowpack basically each day. And you can see here that got the little arrow there pointing to 20, 21, 22. This is by far the highest snowpack since this station went in 1989. And I've also highlighted there the last couple of years just for reference. But not only was it a lot of snow on the ground, it was also the latest melt out that we had of the snowpack since 1989. So really, not just the terrible rain in December, which added a lot, but even beyond that, it was a pretty darn snowy winter last year, and in some ways, record setting and record late melt, and that's of course very important for your work. We can extend that record back even farther. In the Delta area, there is what's called a snow course near Shaw Creek. This is a site this is manually measured snow water equivalent. It's done around the first of the month. We're fortunate to have Shaw Creek because it's one of the longest periods of record. These have been done almost every spring since 1961. And all but a few years, there's included a May 1st, about May 1st, nominally May 1st measurement. Usually, last days of April to the first couple days of May. And of course, in most years at Shaw Creek, the snow's melted out by then, but not every year. But you can see here how this year really stands out. The only year that's even approximately like it was, if you have been around long enough, 1985. That's the year there with more than 6 inches of water in the snowpack still around May 1st. That was a very cold spring, much colder than this spring, that helped maintain that snowpack. But here we see, based on the last 62 years, you can see we're head and shoulders this past spring as far as late in the spring snowpack. Really quite remarkable. And this, of course, was the story basically from Fairbanks all the way to Tok and Northway. Really excessive snowpack in the spring 2022. So we eventually did melt out that snow in mid-May. So here's just a little table, and we're going to use our Delta 20 Southeast Cooperative Station, once a day observations. Nice complete observations from Mike there this summer. And you can see I've just put in the average temperature and the total precipitation, as well as a measure of how those differed from normal. So you can see in the middle column there, average temperature, May was significantly below normal. July, just a couple tenths of a degree, so basically normal. Both, and then June, August, also significantly warmer than normal. September, very close to normal. Precipitation-wise, again, we have that very deep snowpack, and it was wetter than normal in May with the significant rain, a little bit of snow right at the beginning there. But midsummer, quite dry with precipitation less than 85% of normal at this particular station, and then September quite wet. So a dryish summer sandwiched between record high snowpack and spring precipitation, and then a wet end of summer in September. Now, here is a nice little graphic. This is available online. You could do this yourself at home if you wanted to. What I've done here is I just, from this website, scasis.com, you could pull this up, and this is just a plot of the daily temperatures. Here I've plotted Fort Greely from May 1st to the end of September. So the blue bars are each day's high and low temperature there, the range. The red band there plots the record high. Oh, so this is basically since the World War II era, and the blue band is the record lows. And then that kind of that brown band where most of the blue bars lie, that is the NOAA 1991 to 2020 normal. So this is a kind of a nice way to get a picture of how things evolve through the summer, and then also put that in context there. So you can just, glancing your eye over that, you can see relatively warm weather relative to normal there in June, and especially late June up near record highs. Then big cool off during July, and then we see temperatures popping up then again as we went through August and into September. So this is kind of a handy way to do this. Now I know that some folks were impacted by frost. The end of July, Greely was not one of the places that got to that. You can see there in July, the temperature dipped to 38 one morning. First freeze there at Fort Greely was in early August. So pretty early, but not that July freeze. But if we look at our Delta 20 Southeast station here, the same kind of plot here, and you can see that actually did have several days there with temperatures, low temperatures, right at or just below freezing, and then lower temperatures there in the second week of August as well. So this is it shows, it really shows the value of having multiple observations, especially when you have thresholds that are important, like, of course, freezing. So when we put all this together, a few degrees above normal, a few tenths of a degree below normal, what does that all mean? Well, of course, many of you will be familiar with the concept of growing degree days. If you're not, just think of that as growing degree days. It's kind of a measure of the accumulated warmth. And here I just use the Fort Greely temperature data. Now, the way this works here is the brown line is the 1991 to 2020 normal accumulated heat, normal as defined by NOAA, and the green line is just accumulated values for this season. And this is a base 50, so all this does is for each day that the average temperature is above 50, you subtract 50 from that, and then you just keep a running tally of that. And you can see once we finally did warm up in the last days in May, we pretty quickly got above and stayed above the total accumulated heat. And of course, this is quite important for many aspects in agriculture. Many crops are quite sensitive to this accumulated heat. And so it's something that is quite of interest from gardening on up to larger scale agriculture, depending on the crops involved. Now, I previously mentioned our climate analysis models, and I wanted to show you what that looks like here when we're looking at a whole seasonal precipitation. So I've zoomed in kind of close here into the region, and on my little graphic there, I've indicated some places to help orient you. I've also put on the roads there and the rivers, so hopefully you can see all that. But what we see from our climate analysis model is, first of all, the thing that first jumps out at your eye is how wet it was across South Central and the Gulf Coast, Valdez, Anchorage on up Talkeetna, and much of the Parks Highway area, extremely wet, as you probably know well if you made any trips to South Central this summer. Also quite wet in the Alaska Range, but on the north side of the mountains, generally near to a bit below normal precipitation. Delta area, as we saw from the station data, was kind of not that far from normal, but places like Fairbanks and then over towards Tok were drier. Again, not dramatically, but it was a pretty sharp contrast to the wet in South Central, all across the eastern interior. So now looking at the station data, same plot here, kind of plot as the growing degree days. So the brown line is normal, and the green line is just the accumulated precipitation. In this case, I plotted up April 1st through the end of September. And this is for our Delta 20 Southeast station. And you can see that the green line is, most of the time here, is below that brown line. Brown line's normal, but not dramatically. Total precipitation is on the vertical axis there. So below normal precipitation accumulated through the warm season, but not dramatically far below normal. Keep that in mind as we go to our next plot here from Fort Greely. Now here you can see there's a bigger spread between the normal, the brown line, and the accumulated precipitation this past warm season, April through September, at Greely than compared to the Delta station. And you can see there where there's flat, straight lines there, longer periods with no appreciable precipitation like there basically the last 2 weeks of July, or I'm sorry, the last 2 weeks of June into the first 10 days or so of July. Quite a dry period. It's not uncommon to see these kind of differences across stations in the summertime, especially early summer, when so much of the precipitation is often shower, thunder shower, real hit or miss. So again, we really need those multiple observations to help assess what's been going on with the climate. Now, although we wound up extremely wet across south central and western Alaska for the summer as a whole, it sure didn't start out that way. It was actually quite dry in the spring and early summer, to the extent that we did have drought analyzed on the U.S. Drought Monitor for part of the summer. Now, we never did get to drought or even that abnormally dry category to the Delta area. Even though the early summer precipitation was below normal, most places wasn't that far below normal, but because we had that very deep snowpack that lasted to record late, that was another factor in protecting the Delta area from any kind of drought designation there. July 5th, this was near the peak of this, and of course by the end of July, this had been really reduced greatly as the fire hose got turned on western and south central Alaska. So last little piece of the puzzle here for today's presentation, take a look at some of the longer term trends and some of the things we've talked about here today. So April snowpack trend. So what we're looking at here is the average amount of water in the snowpack for the month of April from our climate analysis model. And I'm showing you here a 50-year trend. Nothing magical about 50 years. I like to do that one. It's a nice half a century, nice round number. And that's also works out as the better part of an adult working lifetime memory. I can certainly remember before 1973, but I certainly couldn't place the snowstorms I remember in any kind of context from my own experience. So that seems like a decent reason to use 50 years as well. But again, it's arbitrary. We could do longer or shorter periods. That said, what we see here is that over most of the interior, we see a trend towards less water in the snowpack in April. Now, Delta is, if you'll notice there, if you look real close, it actually is in an area there with very little change. There's more substantial change to the west up towards Fairbanks, and then even from west from there, as well as in the upper Tanana Valley, 40-mile country, you see there's also a more substantial decrease, but not so much in the Delta area. Now, why would that be? Well, it may just be statistical variability. You can see there's a lot of portions of the northern interior there, north of the Yukon River, that aren't showing much trend in April snowpack. Another possibility, or an additional possibility, I should say, is that, of course, because Delta often has some of the lowest snow in the Tanana Valley because of the mountain shadows, is very efficient in the Delta area, and also because of the wind and the redistribution of the snow by the wind, snow depths are often lower in the Delta area than other portions of the Tanana Valley, and so there's less room to drop. That's just speculation on my part. But the overall trend is down, but not dramatically lower snowpack in April for the Delta area. Now, how about summer rains? Well, again, looking at a 50-year trend since 1973 to this summer, you can see here the scale is not the same as the last map. That first shade of the tan colors, it's only a 5 to 15% drop. It's not nothing, but it's not very much. I would put that in the really, there's no significant trend. Maybe there's a little hint there of a drier trend, but I would not call that robust at this point. Very different than what we see, for instance, there on the Gulf of Alaska coast, east of Valdez, where there's been a really super increase in the percentage of rainfall coming here in the summer. And I've zoomed in here so you can't see it. I think that Gulf of Alaska increase, that is probably related to a shift in the storm track over the past 50 years, because back over the Aleutians and Alaska Peninsula, there's actually been a drying trend in the summer. Not strong, but drying trend. And that drying in the west, wetter in the east, that looks like a storm track change to me. But that's not penetrating north of the coastal mountains, as you can see, really much at all. Now, the early season frost here, interesting and impactful for some folks. This is some work, ongoing work I've been doing with the changes in the growing season. Now, the way we usually do this in climate world is growing season is really the freeze-free season. So when the reported temperature is 32 or less. So what's the longest duration that the temperature stays above freezing? And here I've constructed a 60-year trend, 1952 to 2021. And actually what's plotted here is nearly every single station that we have consistent records for over that time. Most places are having longer spans of freeze-free, but not everywhere. And notice that Fort Greely is one of the places that has a significant, at least a lowering, a shortening of that freeze-free season. It's 10% is non-trivial, but you'll notice it's surrounded by places with significantly larger increases. But it's not the only one. Very slight change at Glen Allen, a very minimal change there at Bettles, but not the big increases like we're seeing in other places. Now, why would that be? Well, there's one, it could just be local variability. We know that growing season is extremely sensitive to really not just local, but really very tiny scale factors. So for instance, in the Fairbanks Bowl, I'm not talking about the hills, just around the Fairbanks Bowl, the growing season varies by more than 3 weeks. The average growing season varies by more than 3 weeks. Again, that's not counting the hills, all in areas that look like they should be climatologically similar. So that could be part of it. Could be just that Greely is in a cold hole. We know it's not particularly in a cold hole relative to some other places in the area. Certainly not like Clearwater Lake or anything like that. Another possibility, or I should say another additional factor that is possible, is that when the automated weather station was installed in the late 1990s, it was installed off of the runway, well away from any buildings. That's very different from where it was prior to that, where the temperature equipment was, which, if you remember, was just outside that old FAA building that was just off the end of the runway there, and you could see it from the highway there. So A little bit, maybe the current location is a little bit colder. Maybe the old location was building infected. I wouldn't think that would be a big deal, but it's a possibility. Short answer is that even though overall in Alaska growing seasons are increasing, as you can see, there are local differences that are bucking that trend. So that is what I have for you today. I hope this was of some value for you. My email contact is there. As you know, probably, we do have our Alaska Changing Environment publication that's on the International Arctic Research Center website. Right there's the address. We also have one that's specifically about changing wildfire, if that is of interest to you as well. Obviously, here in the interior, wildfire is almost a big deal as freezing rain. So check it out and feel free to get in touch, and hopefully I will now be able to take any questions you may have. So, okay, thanks.